you're asked for this, you've got to work out the equation of the steepest perpendicular bisector. And we've got a choice of 3. Okay. So I would personally say, well, the perpendicular bisector of these 2 points is that. That's not very steep. Obviously, it's shallow-ish. This one here, that's negative, steeper, so it's definitely the steeper of the 2. And this one here, well, it's a bit of a measure, isn't it? It is hard to judge that one. So maybe we need to just work out the gradients. We've identified that this one is definitely not going to be it. So maybe we should just work out the gradient of the perpendicular bisector for that one and the gradient for the perpendicular bisector for that one, because that's clearly going to determine which one's steeper. Okay. So if that's the case, I would take these points, which are, let's just put the numbers in, 4, 1, 10, 4, 2, 7. Nice whole numbers, make it absolutely basic to work out. And so let's work out the gradient of this guy here. What's the gradient of that one? Okay. What you meant to say is, oh, rise over run. The rise is 3. The run is 6. 3 over 6 is the gradient. That's the gradient of this guy, which is a half. Now, that's the gradient of the side of our triangle. It's not the gradient of the perpendicular bisector. So therefore, what's the gradient of the perpendicular? Minus 2. Absolutely right. Flip it over, put a negative in front. So this one has a gradient of negative 2. Now, we don't know whether that's going to be the winner yet, because we're going to now do it with the other one. So let's just get rid of all that. And let's do that again. So let's look at this line. What's the gradient of that line? Gilchrist, what about you? What's the gradient? Nothing really matters, Gilchrist, but go on. What's the rise?
3.
Well done. This bit is 3. From there to there is 8. Okay, so what's the gradient?
3 over 8.
Yep, but it leans backwards. So the gradient is minus 3 over 8. But again, we don't want the gradient of the line, we want the gradient of the perpendicular. So what's the gradient of a line perpendicular negative 3 over 8? Yep, which is 8 over 3, of course. You flip it over, change the sign, we get 8 over 3. And is 8 over 3 bigger than 2? So the gradient of this perpendicular one is 8 over 3, which in fact is 2 2/3. Not that I'd write it like that, but just for comparison, 8 over 3 is in fact steeper than the negative 2 line. So that little effort was just to find out which equation we're going to find.
So,
Hello.
I get it right up until the last bit. How do you know if it's bigger or not? Like, because how do you know if 8 over 3 is bigger than 2?
I might just repeat that for those of you who can't hear. The question was, how do you know that 8 over 3 is bigger than 2? Okay. Any suggestions out there? You either do the conversion from 8 over 3 to 2 2/3, which is clearly bigger than 2 because it's like got that 2/3 bit on it. Okay, not wanting to sound remotely sarcastic or anything, or condescending even. But that's one way of doing it. Or if you're not that into conversion of fractions, you could go 8 divided by 3 on your calculator and it'll go 2.66666, which is bigger than 2. I'd like to think you could do the former, in fact, this. Okay, because 6 over 3 is 2, isn't it? 6 over 3 is 2, 8 over 3 clearly a bit bigger than 2. But there you go. I'll edit that bit out later. So what we've discovered is we've got 8 over 3 as our gradient. And the 8 over 3, which is this line, is the steepest, or it's the steeper, of the two that we decided were contenders for the steepest. There was this guy, which turned out to be, this down here. So this one gave us -2. This one here gave us a gradient of that. Therefore, it's the winner. So the question says, find the equation of the perpendicular bisector, which is the steepest. Now we know which is the steepest. Let's work out the perpendicular bisector. So all of that working there was...
It doesn't matter if it's
No, steepness is steepness, whether it's negative or positive. It's still just steepness. So this one here is the line that gives us the 8/3 one. Okay? So what do we need for an equation of a line? Rhetorical question. Y minus y1 equals mx minus x1. And we know the gradient. We know the gradient. It's 8/3. You're actually given it. That's the only equation you're given. But, I mean, we use it so frequently, it's almost impossible to forget. So the gradient is 8 over 3. So all we need is one point for which our perpendicular bisector to go through. And which is that? The midpoint. So our perpendicular bisector splits the line into two pieces and heads off at right angles. And we want the equation of that. We know the gradient, so we just have to work out the midpoint of those two. And the midpoint's the average of the x's and the average of the y's. The average of the x, 2 and 6, 2 and 10 is 12, halved is 6, 7 and 4 is 11. Annoyingly, half of 11 is, and I'll write it as a decimal, 5.5. So that point there is 6, 5.5. Okay. Now, that's just the midpoint. It's just the straight midpoint of that guy and that guy. Because the perpendicular bisector...
Was that the average of the x's and the y's?
Correct. The average of the x's, 2 and 10 is 12, halved is 6, 7 and 4 is 11, halved is 5.5. So we've got our point, we've got our gradient, we've got our equation that uses gradient and point, and we just substitute them in. And so what we write next is, therefore, y minus, I'm going to write it as 11 over 2 because it's tidier than the 5.5, in my opinion. And there's our 8/3 as the gradient, x minus 6. We do a straight substitution into the y minus y1 formula. And our job then is to just rearrange that and make it look tidy.
So that's the equation for the
Bisector, correct. Okay. So I'm going to now, what would you multiply through by to get rid of the fraction since we've got two of them? What would be a safe bet? 6. I'm just going to multiply everything by 6, and that becomes 6y. Yeah, 5 was a goodie.
Why do you have to multiply?
Well, I just want to make it more simple. You've got to write the answer in either y equals mx plus c form or standard form, and at the moment it's not in either. So if we put it, all we've done is we've substituted in the equation, so this is the answer. This guy here is it, but it's not written in correct format, so we have to just rearrange it. Y minus 11 over 2. So I'm going to times everything by 6. That means this becomes 33. This becomes 16. X minus 6. I've just multiplied it by 6 just to get rid of the denominators. Because it's the lowest common multiple of the 2 and the 3. If I multiply that by 6, then the 6 cancels with the 2 and turns into a 3. 3 lots of 11 is 33.
Is it wrong if you times it by 3?
No, but if you wrote 5.5 here and then multiplied everything by 3, absolutely fine. All you're going to end up with is a decimal in your...
Still in half of
It'll be half of all of this, yep. This way, you guarantee there are no decimals and no fractions. But yeah, you'll end up with, in mine there'll be one odd number, that 33 will be there, and you'll have a, 16.5 or something. Okay, yep. Oh, that's right, because there's going to be more of this. Now, 6 16s are 96, and that's 6y minus 33, and then I just chuck everything onto the one side, and I get 16x minus 6y minus 63, something like that.
So how did you choose 6?
Because it's the lowest common multiple of 2 and 3.
Oh, yeah.
I just wanted a single number to get rid of it. Now, I only wrote this because it's just nicer using fractions than it is using decimals, but if you did it with decimals, you'd get this. And you'd multiply everything by 3 because that's what we do, and you get 3y 16.5 48. Just expanding the bracket, so that's getting rid of the 3, and then you'd end up with your final answer of 8x minus 3y. What's 48 minus that? It's about 31.5. You'd get that as your answer, which, if you look at it, is exactly half of mine, which is fine. They're the same thing. This one has still got a decimal in it, which means the purist would really want that as the answer because it doesn't contain decimals or fractions. You could then just double everything, yeah. This is, both of these are general form. So the answers, I'm picking that, the answers at the back of the book would probably have that, and they do. Okay, but this is totally acceptable as well. Okay. So, moral of the story, that question has been made more difficult because you don't know which one they want, and you have to do the gradient thing first. But once you've got that gradient, it is sort of textbook perpendicular bisector. Right.